Okay, this is the project I did for graphics. I'm just going to show it first. That way we can see it running. It has WASD motion, so we can move around. That's global, so if you rotate, it will be off axis, which is acceptable, I think. And then rotation. This isn't the most amazing rotation code. It could definitely be improved, but it does work for now. And then up and down. And then if you right click, it deletes a cube. And if you, there we go, delete everything. So if you left click, it sets a new cube at the first open spot in that column that's above where you clicked. So if I click here, and then I get rid of this, if I click this green cube, it's going to go above the green cube, not above the pink cube. So, which I think makes more sense. That's pretty intuitive. So, and then the colors are randomized, so they're different every time. So now let's go show you the code. Open that up. Go to the scene class. That is where most of the stuff happens. So this delegates all the rendering to the objects. So this just handles initialization, selection, mouse callbacks and stuff like that, and then loads the scene right here. So I'll break some of this down. So we enter and we do the initial get initialization, which calls the load scene, and that's just brought to a different function for style purposes. It could easily be in the scene init, but I wanted to make sure that the scene init was something that would always stay the same, basically, for all scenes. That way we wouldn't have to change that every time. So this is what would want to be changed for a given scene. And then we're creating all our buffers and our camera, and we're setting it to the initial position, and then we're creating our basic cube, and then we're creating our basic light, and then we put the light into the vector, and then we this is creating the initial grid of cubes. So all of the cubes are already there. They're just all except for the bottom row are invisible. So when I click on them, I'm really just setting them active or inactive. And I did that for performance reasons. That way I wasn't overlaying cubes, because there wasn't a really great way to do that without a 3D vector anyway. So I figured I might as well just have them all initialized, because their memory footprint's fairly low. So they just get set active or inactive based on how we click. And then the render, we call the camera display function, and then we do the light display function, which is called update shader, because you don't need to do this unless a light has changed. I don't have that check in here, so I can change that. Check if light has changed. So that doesn't necessarily have to be done this way. That's like a improvement that we could make. And then we just swap the buffers. So if I go to the basic object, this is where all the rendering for the objects happens. So we check to make sure that we have a position and normal pointer for the attributes, and then we send over the model view and the color depending on whether or not we have a selection flag enabled. And then we draw the erase. And if it's drawn in the select color, it will get set back before the next frame. So, and then we've got some helper functions for sizing and moving. And then to go to the mesh, we've got basically just a little container wrapper around the vector for the mesh, for the mesh coordinates and the normals, and then has some handy inline functions for getting the size of the the index into the buffer for where that mesh is actually located. And then look at the light. Also really simple. Just a few lighting values, and then a really simple just update the graphics card with the new values. Though the camera has the projection and all of that in here, and functions for resizing and moving and changing the look at point. And the display just sends over the camera view, and that should also probably be checked to make sure that it hasn't changed since the last time we've done it. That way we're not eating up bandwidth for eating up bandwidth between the CPU and the GPU for no reason. There's a word for that, but I can't think of it off the top of my head. And then the derive class actually does do a little bit of sending. This sends over the buffer data. This buffers the points, but I think I could put that on the mesh as another abstraction. That way I just initialize the mesh and it just handles that for me. So that's another improvement I think I'm going to make. And then vShader, just basically taken from the Lecture 22 vShader. There's been a few small things, like I had a test vector in here to do some debugging with the normals and such. And I believe otherwise it's the same. Yeah, and then into fragment shader, pretty much the same, except there's a flag to render as a selection instead, so it doesn't do the whole lighting equation in that scenario. That way the whole object is the same color. And I believe that, I have a material class too. This just has material properties and also does a little bit of sending data over in this scenario where we need to update material properties. And that should also probably be checked to ensure that we're not eating up that bandwidth. Though the select render, actually no, it would need to be done every time, which is what I'm doing right now, because each object has a different material. It's not like the mesh where each object shares a mesh, so I don't have to change it between objects. But each object has a separate material, so I still need to call it every time. Okay, so I believe that is everything.